Peace be upon you and may Allah's mercy and blessings be upon you. Hope you are well. The purpose of this channel is to understand statistics from every aspect. There is an excellent series of questions and answers, which will make it easier to understand the topic of statistics. So I request you to subscribe my YouTube channel. Let's start today's video. In this video we will discuss about question numbers 13. Define quartile deviation, or QD, and give its important features. Question 14. For a symmetrical distribution, how can one determine the upper and lower quartiles with the help of quartile deviation? Question 15. What are the good points of quartile deviation? Question 16. Throw light on mean deviation, or MD. Question 17. Discuss coefficient of mean deviation. Question 18. Write the merits of mean deviation. Question 19. Mention the demerits of mean deviation. Question 13. Define quartile deviation, or QD, and give its important features. Answer. It is half of the interquartile range, i.e., Q3 minus Q1, divided by 2. It is an absolute measure of dispersion. Hence, to compare two series, a relative F measure known as coefficient of quartile deviation is given, which is symbolically expressed as Q3 minus Q1 divided by Q3 plus Q1. Question 14. For a symmetrical distribution, how can one determine the upper and lower quartiles with the help of quartile deviation? Answer. For a symmetrical distribution, the upper and lower quartiles can be determined by the formula Q2 plus QD and Q2 minus QD, respectively. Question 15. What are the good points of quartile deviation? Answer. Following are the good points of quartile deviation. 1. It is easy to calculate and understand. 2. It can be calculated in case of open-end frequency distributions as well. 3. It is not affected by 25% upper and 25% lower extreme values. Question 16. Throw light on mean deviation, or MD. Answer. Range and quartile deviations are positional measures of dispersion, whereas mean deviation is a measure of dispersion which is based on all values of a set of data. It is defined as the average of the absolute deviations taken from an average, usually the mean, median, or mode. It is usually denoted by sigma. To clarify whether the average used in mean deviation is mean, median, or mode, a suffix is attached to sigma, such as sigma MD, or sigma m. The formula for calculating mean deviation of n observations x1, x2, up to xn is sigma equals 1 divided by n sum of absolute of xi minus a. For I equals 1, 2, up to n. Also a may be any chosen constant out of mean, median, and mode. For a frequency distribution in which the variate value xi occurs fi times I equals 1, 2, up to k, the formula for mean deviation is sigma equals 1 divided by n sum of fi, absolute of xi minus a, where sum of fi equals n and a, as defined above. Here, it is worth emphasizing that mean deviation is minimum about the median. That is why median is commonly used as an average value about which the mean deviation is calculated. Question 17. Discuss coefficient of mean deviation. Answer. Mean deviation has the same unit of measurement as that of the variable x. If two series have different units of measurement, the series cannot be compared. Hence, for comparing any two series, an unitless measure is given known as coefficient of mean deviation. It is the ratio of mean deviation to the average, A, used in calculating it. Its formula is coefficient of mean deviation is equal to mean deviation divided by A multiplied by 100. It is multiplied by 100 to express coefficient of mean deviation in percentage. Question 18. Write the merits of mean deviation. Answer. Following are the merits of mean deviation. 1. It utilizes all the observations of the set. 2. It is simple to calculate and understand. 3. It is least affected by extreme values. Question 19. Mention the demerits of mean deviation. Answer. Following are the demerits of mean deviation. 1. The foremost weakness of mean deviation is that in its calculation negative differences are considered positive without any sound reasoning. 2. It is not amenable to further algebraic treatment. 3. It cannot be calculated as case of open-ends frequency distribution. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon for latest updates.